Hello again to all my friends. Greetings, Earthlies, parents, pets, cats, dogs, whoever you are. We just had this conversation, but does anyone have a better introduction?
I like dogs.
I like dogs. I don't think that's an introduction.
It's an amazing introduction.
Anyways, class can say hello.
Hi.
And previously, before we had to leave that video, we drew some smiley faces. We drew a SpongeBob, who isn't really SpongeBob apparently, because he's not wearing a hat, which I've never seen. Okay, Krusty Krabs. Yeah, he wears a Krusty Krab on his head. A little anchor on his hat.
Where's his nose?
There.
No!
Anyways, this is, forgot to mention, 2D geometry. Someone close the door, please. Thank you. If you can't tell from that beautiful melange of words and figures. We have grids and plotting. We have translations. We have reflections. And we have congruence and similarity.
I'm doing that one.
I'm doing that one. All right. Let's start off with grids. So students number the first will come on up. And students, I'm going to draw you a grid, and I want you to label it for me, okay? And I'll tell you what things I'm looking for.
That is an awesome.
Oh, it's not very straight. Okay, I'm sorry. Whatever. So, first I want you to tell me what axis, or which axis. Okay, I'm going to have to rephrase this. Where's the x and where's the y axis? And how do we remember this usually?
I think X is right here.
X? No, that's not where x is.
Oh, X is right here.
Well, no, those aren't axes. You're plotting
X,
coordinates. Yeah, that's where x is.
X.
So can you erase that x? Because we don't want that there.
Can't remember how to erase.
Erase, go to the eraser. There you go.
Oh.
You can highlight it as well if you want, but that's no good. So this is the x-axis. Now how do we usually remember that? Someone's on the ground. It's okay, you can walk in front of that sign. I heard it on that. Xavier, Professor X, he's on the ground, unfortunately. That's just how we remember it.
Oh, Y.
And Y. Yep, you can put Y there. Beautiful. X and Y axes. Now, what is always at the middle of this grid?
A circle.
Whoa, it's more than a circle. What is it?
Oh.
It's a value represented.
A dot. Got it.
It's a sideways G.
Yeah, it's a sideways G. So what we have there is actually a 0. Why is there a 0 right at the middle of our grid?
I don't know.
That's the origin point, right? That's 0, 0. Right? Now, when we're reading, we're trying to... Come back here. When we're trying to label, let's say my point is 5 and 4. Which do I read first, the x or the y axis?
X, I think.
X. X is always first. And then y. So, if this right here is 5, and I'll say that's 5 as well, this is 5, this is 5. Did I do anything wrong there?
I don't know.
I think I did. Can anyone tell me?
You put 5 where on the X or Y.
Well, yeah, it's still 5.
We didn't put them in
Negatives, that's right. This side is negative and that side's negative, right? So we have to keep that in mind. So, students, can you tell me where points 5, 4 will be? Well, you said we read the x first, right? So where do we go?
X and then go to the opposite side of X, I think.
Ooh, which side? Am I going to go here or am I going to go here?
Here?
That's right, I'm going to go on this side because it's positive. Now, I'm going to go to the 5. Is that where my point goes?
Yes.
Try again. That would be 5, 0. That's not what I want, right? What do I want?
Positive?
I'm at positive 5. What am I missing here?
I do not know.
What's the next coordinate?
4?
4. So I got to go up 4 onto y, right? So that's that point right there. And if this point had a name, let's call it J, that would be J. Good? Fantastic. Thank you, student. So that is just your basics of plotting. Now what I'm going to try to do is, I'm going to try to copy this, see if that works out. Copy. Let's hope. So I'm going to place it right here. Did it work? It kind of worked. I have this G in here right now that I'm going to erase. I'm going to erase all that. And that. And I'm going to keep those. Now, where is student number the second? Student number the second. I want you to transform this dot. Ooh, you know what? I should move that a bit. That's okay. That's still at 5, 4, okay? I want you to transform this dot to any place you choose, and I want you to tell me what you do.
Okay.
Or what you've done.
So I'm going to transfer J
Or translate, sorry, my fault.
translate J to negative 5, negative 5 and a positive 4. So 2, 3, 4, right here. Okay, I didn't.
What's happening?
It's not working. Okay, there we go. So then we label it J prime
Ah, why is it called J prime?
because we moved it.
Because it's been moved, right? It's no longer J. There can't be two J's on the same grid. Or could there? No, we have J prime because it's been moved.
And then, so what I did is I just translated it over to the left 10 spaces.
So we can write therefore.
So, therefore, J prime is at negative 5 and 4.
Beautiful. Thank you so much. Now, Sue, before you go, if by chance I had made a triangle here, could you do the same thing with the other points? Say they were S and G. Could you do the same with those 2 points? Yeah, and it would end up being something like that, right? And what would be here? Would it be S and G as well, or would it be?
S prime and G.
S prime and G prime. Very good. So it doesn't matter if it's 1 point or a whole shape. You can always translate. Very good. Now, we're going to reflections. Student number the 3rd. So, I'm going to try to draw another grid, and hopefully it won't be questioned as to whether or not it's straight. So I think that looks pretty straight. What do you think?
No, it's not straight.
No, okay, it's not straight. Okay, that's fine. All right, now we're going to have to draw some sort of a shape to be reflected. Nope, sorry, can't. All right, let's do a triangle. Who?
What about an octagon?
Who? Who? Now, I'm going to give you the choice. Do you want to reflect this on the y-axis or on the x-axis?
X-axis.
X-axis, go for it. And let us know what you're doing.
Okay, so
Whoops. Uh-oh. Made a mistake. Good thing. A student caught that. Reverse. I mean backwards, backwards, backwards. This should be the x, and this should be the y. See? Mistakes are made. Okay, go ahead.
okay, so it's 4 up, right?
Hmm?
It's 4. What is it? 4 positive.
Yeah, so right now, that point, if you want to label each point, that's at 2 and 4, right?
Okay, so
Uh-huh.
2 and 4, and it's 2 across, right?
2 across, that's right. The silence is deafening. So where are we trying? Are we trying to reflect it on x or y?
We're trying to reflect it on y.
We're trying to reflect it on y. So the way I like going about it is I'm going to take, I'll use black, and say that, okay, so we have 1, 2 spots away from there, right? So I'm going to go 1, 2, and that's our first point. Now I'm going to get rid of all that because it's kind of messy. But I know that's my first point. Now that's point, we'll call that point A. So that's now point A prime. If we call this point point B, where should point B be? BB.
Point B should be.
Well, if A is here and A is 2 spots away, how many?
It should be 2 more spots.
2
right?
more, exactly.
Why is this happening to me? And because the okay, so that would be B prime, right?
B prime. Very nice.
Yeah. Okay, whatever that is.
Student number the 3rd. Come on, get the turn on. And we're missing 1 point on this beautiful triangle.
It is point C, right?
Sure, it can be point C.
It's 3 points away from the.
3 points from the top. Very good.
So it's right there. So point C.
C prime. Very good.
Yeah, this is the C prime.
Okay, we know that's C prime. And now?
We just connect the lines, right?
Connect the dots.
There we go.
Beautiful. That's a reflection on
Give
the
me a
y.
smiley face.
It's a
Yeah.
triangular smiley face. It's a
Yeah.
really, really happy piece of pizza.
Yeah.
Now, if we wanted to label each point A would be at 2 and 4. B would be at, whoops, 4 and 4. And C would be at, what's this, 3 and, oh, it's a lot. 1, 2, 3, 4, 5, 6, 7. 7. 3 and 7. Now, if we're labeling points A, B, and C, we should also do A prime, B prime, and C prime. Now, we can just look at a reflection and say, well, it's at now -2 and 4. B is at -4 and 4. And C is at -3 and 7. So we see the same values, just with a negative sign, because it's flipped on our y-axis. We could also flip this on our x-axis, and it would look something like that. Again, just count the numbers and see the difference. Then our last addition, or our last question, is congruency and similarity. Student number the 4th, go for it. Explain what they are and show us an example.
Alright, so something congruent is the exact same thing, basically. Draw something. I don't know what to draw. Teacher.
Go for it.
Alright, I'm gonna... Something.
Something.
Yeah, it's a square. And then it's the exact same square.
I don't know. If my lines weren't straight, I don't know if that's the exact same.
Just don't worry about it. Just pow. It's a circle around the square. Alright, similar things. Similar things are almost the same thing. They look similar, but they're different in things. Yeah.
In what?
In different things. Yeah.
Something about them is different.
Yeah.
Something is the same, something's different.
Yeah, so there's a square and then another square. Yeah. And those two are similar
Why are they similar?
because they're both red squares, but then this one
Uh-huh.
is bigger.
See, I'll show you what we can do with technology these days. You want to see a square? Bam! Nice square. Actually, it's more like a rectangle, but whatever. And now, I can take that square, and I'm going to copy it.
It's not fair.
And paste it.
I didn't know how to do that.
And... no... Oh, I'm just making more... Okay, anyways, these two, because I've copied them, they are congruent. But if I were to make another square, say like that, these two are similar but not congruent. Oh, too many squares. Undo, undo.
The projector's so hot.
I know, that's how it works. It's giving off a lot of heat. I'm going to erase your squares here, sorry.
Not very energy efficient.
Well, it's not energy efficiency, so it doesn't explode. It needs to release heat. These are similar. What is different between this and this?
Well, for starters, they're not the same length.
Not the same length.
Not the same length and width, and then yeah.
But are their interior angles the same?
Yes.
So, interior angles are all the same, but not the same length. So we can say that similar triangles don't have, or similar squares, don't have the same length.
Yes.
Congruents have same length, or same sides, really we should be saying,
And same interior angles.
and same angles. Interior angles.
What would be the exterior angles? Like,
Okay, so I can draw an exterior angle if I do a triangle. These are all interior, right?
Yep.
Now, if I were to draw a line here, this angle right here is the exterior angle.
Oh, so
That equals 180 degrees. We're going into a different conversation here, so we're going to get back. So congruency and similarity. Now, if I were to tell you, I have a triangle with sides that are each 6 centimeters, and I have another triangle with sides that are 7 centimeters, what would they be?
centimeters.
7 centimeters. It's hard to say.
They would be similar.
They'd be similar, right? Not congruent because they're different sides. And anyways, I believe that is it for this video. So, we'll draw our happy face. Eyes are really far apart there. You know what? Let's give him some congruence glasses here. I'm going to make this a bit thicker. Oh, too thick. There you go.
Don't seem very congruent.
Da-da-da-da-da. Yeah, and the lines aren't straight either. Anyways, he's got glasses. And what do we say?
Was that supposed to be me?
No. Thank you. In pink highlighter, so it's kind of hard to see, but that's okay.